morning from the cloudy Copenhagen and welcome to the training session Energy Efficiency, eTraining to Mozambique, hosted by Copenhagen Center on Energy Efficiency. My name is Begonia and I'm working as a research assistant at the Copenhagen Center, and I will be the moderator for today's training session. A couple of things before we move to the main content of this training. The training session is going to be about 90 minutes long, including time for Q&A at the end. In case you cannot stay until the end or want to get back to our presentations, all the materials and recordings of the whole training session will be available online in a few days on the Copenhagen Center's Knowledge Management System. And we have many other webinar and training sessions there. Have a look. I will give you more information in a few minutes. Before we start discussing about today's training session, I would like to inform our attendees that we comply with the General Data Protection Act, also known as GDPR. This means that your personal data, such as name, email, workplace, is safely processed and stored, and all of your rights pursuant to the GDPR are respected. You have full access to the data being processed about you, and at any time you can request that inaccurate data be deleted or rectified. For access or further information, please contact with the people that are presented here. A few things about the Copenhagen Center. The Center conducts research and advisory activities in the field of energy efficiency and serves as energy efficiency hub for the Sustainable Energy for All initiative. The Center has an established network of global, regional, and national partners with a broad range of stakeholders to help accelerate the implementation of energy efficiency activities. Now, I would like to briefly introduce you to the speakers of today's training session. Frederick is a technical and policy lighting expert, graduating in electrical and electronic engineer with more than 35 years experience in the lighting industry. As international lighting specialist for United for Efficiency, Mr. Bass supports the development of technical tools and resources such as the Lighting Model Regulation Guidelines. On the other hand, Bruno Lafitte is a lighting energy efficiency expert with more than 15 years of professional experience within the sector. He holds a PhD in physics and a master's degree in electrical engineer. As international lighting specialist for United for Efficiency, Mr. Lafitte provides support in the development and implementation of energy efficiency policies and labeling programs for on and off grid lighting in country and regional projects. Our other panelist, Clara Camarasa, she is a researcher and project manager with more than 5 years of experience in the field of energy efficiency in the building sector. At UNFDTU, she is working as a postdoctoral researcher, and in the last 5 years of her career, she has focused on generating building data, along with other analytical frameworks needed to describe and accelerate the diffusion of energy efficiency technologies. Our last panelist of today's training session is Raju. He's a senior expert on energy efficiency. And at UNFDTU Partnership, he focuses on the analysis of policy issues, conducts qualitative and quantitative studies, providing technical advice and other direct support associated with energy efficiency in countries and cities. Finally, I would like to inform that you can send us your question during the presentations, and we will do our best to answer as many as we can at the end. For today's training session, we will have 2 Q&A sessions, one after the presentations of Frederick and Bruno Lafitte, and the last Q&A session after the presentations of Clara Camarasa and Rahul Raju. And now I would like to give the floor to Frederick Bass. Frederick, the floor is yours.
Well, thank you for that kind introduction. And I'm Frederick Bass, more familiarly known as Fred, and I will talk about the minimum energy performance requirements for lighting, the opportunity for lighting in energy saving, and Bruno will follow up with case studies. Just a word about United for Efficiency. This is an initiative of the UN Environment, and it provides a policy framework to accelerate energy savings for climate mitigation, saving carbon emissions and so on. But you'll hear a lot more about this policy framework on a presentation on Thursday, and I will go straight into discussing lighting. Just a snapshot of some of the data that we collect as part of the program. This is A macro view worked at top level in Africa, worked down into through socio-economic data into this status and opportunity in Mozambique. And as you can see, there is an enormous opportunity. If nothing is done with energy saving activity in lighting, then there'll be a slight growth over the next decade in the consumption. A couple of % is predicted. But if you introduce just basic policies, there's an opportunity to save 10% of that. So it'd be 10% less, and that saving amounts to 414 gigawatt hours of electricity, which is equivalent to 4 small power stations. It's a huge saving. And if you're more ambitious, you can save even more, and half as much again. So there's an enormous opportunity just looking at the lighting in the marketplace and the consumption of lighting. Lighting itself is an easy win for savings in energy and carbon. The reason for that is simple. You can easily change a light source. So light sources today are so much more efficient than they were in the past. So we all talk about LED in lighting, that's lighting emitting diode. And those types of light sources are just a step change in efficiency. So the lumen per watt is so much more. And you can see here on a split by region from data we've analysed within our working groups that the proportion of older technologies is quite significant across all markets. Even in some markets where perhaps you'd see there's more penetration of the LED in dark blue, there's still a huge opportunity to replace the conventional light sources with sources that are more efficient. In Africa, of course, with this huge continent, the penetration of LED is less than 10%. So there's an even bigger opportunity in Africa. So if you just follow my bullets there, you can see that fluorescent light sources, that's general service lighting and linear. General service lighting could be also called maybe compact fluorescent. It accounts for 50% of the installed base overall, and the saving of LED is 50%. So these are big numbers in terms of electricity savings. Incandescent and halogen, of course, the saving there is much greater because they are much more inefficient. That's just a wire inside an envelope which is made to glow with electricity. And of course, it's very inefficient. 90–95% of the electricity is heat. In Africa, the situation, as I just said, is there's a bigger opportunity because there's wide use of all the older technologies. And emerging markets are building new infrastructure. So a move directly to LED is an opportunity, and it needs to be driven by minimum energy performance standards. That's setting efficacy levels, which that's efficacy is the word we use for efficiency in lighting, and by setting those levels just at the beginning of LED technology, there's a real opportunity. Lighting itself represents in a typical market where there's no MEPS, 10 to 15% of electricity load, of the whole load. So there's a real opportunity if you can save half of that. And it's so simple with lighting because you just change the light source one at a time, and there's no special infrastructure, special engineering required, or there's no professional involvement. You can just simply change the light source. This is an analysis by the International Energy Agency, and this is looking at the sales of lighting into the markets this is all markets, and it's a very much a macro figure. But their comment in their recent report was basically to raise the share of LED sales to a level which really saves a lot of energy. We need to take advantage of this LED performance and drive it through regulatory policies. And you can see over the years there that the blue is the LED predicted to penetrate the sales of markets. But to drive that, it needs regulation. Just a word about the model regulation guidelines. As I said, it's a policy framework, and we're looking across several different technologies. I'm talking about lighting today, but we're also working on refrigerators, air conditioning, motors, and transformers, all of them consuming electrical energy, all of which can be made more efficient by setting minimum energy performance standards. we always, when we produce model regulation guidelines, and they are intended as guidelines for national authorities to work with, we also produce supporting documentation. And the lighting regulation, model regulations that I'm currently working on, we all have in parallel written a document which will be published together with regulations to support and explain the opportunity and how to introduce those regulations and adopt them into national authorities' rules. Just took some words about what we're working on right now. 2 years ago, we wrote a model regulation for general service lighting. And just in 2 years, the efficiency and affordability of the LED alternative has improved much further. So we're revising them now because it's already looking out of date. We now know that LED is affordable and can replace compact fluorescent, which is 25% of the installed base. So we no longer need to offer compact fluorescent as a low energy option. I worked for a decade offering compact fluorescent as a low energy option, which it was 5 years ago, but it no longer is a low energy option. LED is much more efficient. So, and there's an opportunity to simplify the whole regulation as a result. So we're revising that GSL, and it's in its final stages now. I'm also working on linear guidelines. That means linear fluorescent lighting. We've simplified that, again, in parallel with the GSL, and significant savings can be realized if they're introduced without delay. Fluorescent is a huge proportion of the installed base of lighting, and half of that energy can be saved by moving to LED. And it's not just the efficiency, it's actually putting the light in a more directional way from an LED tube, which, in other words, where you want it. So it's even more efficient than if you just compare the lumen per watt. And finally, linear luminaires, that's light fittings. We're including those because there's a real opportunity as new infrastructure is introduced, particularly in emerging markets, where you're installing new products, new light fittings. And there's a real opportunity just to use an integrated LED fitting, which is the most efficient way to produce light, useful light. So we're including those because the opportunity is to leapfrog directly to installing LED luminaires. And we would propose in regulations that no other luminaire is used in new build because it's simply the most efficient. Just a few points about the simplified approach. What we're working on is setting the minimum energy performance levels at the beginning of the ladder, if you like, of LED capability, which gives you maximum affordability. So the level is pitched above what conventional technology can achieve, and at the beginning of a range of efficacies that LED can achieve. This gives you maximum availability and affordability. We're also simplifying the regulations, so it's just one level per technology. That is one type, lamp type, shall we say, one for linear, one for GSL, and so on. And we also have an energy rating system proposed. So although you might be on the first level of the efficacy ladder for lighting, you can be more ambitious by specifying a higher level, maybe for procurement specification or maybe for more important projects. But in the future, you could also move up those levels through a simple modification of the regulation without having to revise it. There's basic requirements in there to make sure things are acceptable quality. They lamps last long enough. They have no low flicker, so it protects the health of the end user. And we're looking at lining up with the Convention on Mercury, Minamata Conventions, to specify zero mercury. So there's a real opportunity with LED because it doesn't use hazardous substances. We can also eliminate those, and they're very difficult to control in emerging markets and quite hazardous to people's health. So an opportunity there as well. So some conclusions. Conventional lighting is still the highest proportion of the lighting load in the electrical supply. That's everywhere, right? And the LED penetration globally is not even 40%. We have the alternative technology. It's widely available and affordable. And the only way we can drive it is to have some regulation in the market. This will accelerate the energy savings possible across many countries. And if you don't have MEPs in place or they're poorly enforced, basically you don't get a transformation. So we've got basic quality ensured, and our simple approach that we're proposing in the model regulation lowers the barrier to mass adoption. And that's key, because if it's really going to move fast, it's got to be affordable, available, and move fast into the volume market. And the model regulations guidelines can also form the basis of procurement specification for bigger projects. And with the structure of the energy rating system, you can be more ambitious. So as I said, the energy savings lighting is very simple. You just change one light bulb at a time, and that's the end user can do that. So thank you very much. I'll take questions later. I'll now hand over to Bruno, who's going to talk us through some case studies on how these policies have been applied.
So morning everybody. Thanks a lot, Fred, for that. That's very nice introduction. So we've seen that we can save a lot of energy with lighting, but we need for that to replace old lamps, old technologies, incandescent lamps and compact fluorescent lamps. So I will show you some case studies, 3 case studies that countries next to you for Ivory Coast, in Africa, Ivory Coast, in Morocco, and Pakistan, because those 3 countries where I did suggest maps based on the market assessment, because maps is based on what is in the country, are very different one from each other. You will see why. In Pakistan, the first case study, LED were already in the market. Actually, very efficient LED were already in the market. And so for maps, we had workshops, we consist different stakeholders, and we decided to go higher than the model regulation that was the maps that was in the model regulation from 2018. So we differentiate the maps, the minimum energy performance standards, according to the flex, because when you have higher flex, you can have a higher efficiency. And we did that for LED only, because LED were already in place. CFL were incandescent were out, most of it, and CFL were going out. So we didn't have to take care too much of all technologies. So we did maps for lamps, downlights, LED tubes, and outdoor lighting. You see the level are quite high. I don't know if you're familiar with maps for lighting, but the minimum for lamps for general service lamps in residential sector, let's say, 80 lumen per watts is quite ambitious. But stakeholders did want that level, that minimum levels. It was because when we do maps in a country, we have to conduct workshops to ask the different stakeholders what is affordable in the country. First, we know that with market assessment, but where they want to go and how fast they want to go. We will come back later how fast. So for Pakistan, but also for other countries, what I'm doing also is to suggest a labeling scheme. And this is for Pakistan, so it's 5 stars. You can see on the left, 5 stars. 1 star basically is the maps. The minimum level, you have 1 star. Then if you respect the minimum level, but you are more efficient, you can have till 5 stars. So it's depending also on the flex, but you can see here those levels are quite ambitious. For the maximum level, you have 5 stars for more than 140 lumen per watt, and now it's available for street lighting, for an example. It's not widely available, let's say, for domestic lighting, but for street lighting, yes. So that's the labeling scheme we did implement. And what is great in Pakistan, we did begin the work in November 2019, and we will implement the maps. It's in the law by December this year. So it took us 1 year to make maps, to make workshops, to make maps, and to make the labeling scheme. So it's a very good case study. Secondly, I wanted to show you the example of Ivory Coast, because in Ivory Coast, CFL and lead were in the market, are still in the market, but not widely spread, and incandescent were just banned last year. So we decided not to make maps to transform the market and to basically get rid of incandescent lamps, because they are consuming a lot of energy, and we have solution to replace it. But we did maps only for CFL and lead, not only lead but also CFL, because we want to also leapfrog to lead, and because CFL were quite efficient technology before few years ago, but now LED are the most efficient technology, and they don't have mercury inside. That's a big issue in Africa, the disposal of mercury from CFL, from all discharge lamps. And actually, it's a big issue all over the world. So we have to leapfrog to LED, but what we did according to the market, we had to regulate CFL and LED together. So what we did maps as it was in Model Regulation Guideline 2018 for the first two levels, and it was for CFL and LED. The new model regulation will go for LED only, but at that time it was for both technology. So you can see here class 1 and class 2. I present you the labeling scheme with 3 stars on the left, because I did suggest also this labeling with 3 stars, and the two first classes are, let's say the first is for CFL, the second is for LED, and the third is for very efficient LED. Well, we can talk a lot about this, but what I want to highlight is the differences in energy performance. Here you can see for the class 3 level, which is the more efficient level, you have the maps at 80 lumen per watts. Whereas in Pakistan, just before I show you in Pakistan, you have the maps for the basic level from the beginning is 80. So we have to consider the market as it is. That's why all studies are beginning, all our action is beginning by a market assessment and workshops to consult stakeholders, of course. Now I want to go to Morocco. This case study is quite interesting, because in Pakistan we had LED only. In Ivory Coast we had CFL and LED, incandescent were banned. But in Morocco we still have 3 technologies: incandescent, CFL, and LED that are in the market. So what we want to do is to leapfrog to LED, but we couldn't leapfrog directly to LED and say, okay, now you have to buy LED only. It was not possible according to stakeholders, because manufacturers have to adapt, of course, but also because of affordability. Incandescent lamps are quite cheap. So what we decided is to make a 5 years approach, and so we have maps different from years to years. We increase maps from years to years. So I don't want to go into the details from numbers, but you can see the picture here. Of course, LED are above those levels for every years, but incandescent lamps, you see, year 1 we begin to ban incandescent lamps for higher flex. higher than 1,200 lumen. You see on the chart on the table, 1,200 lumen. It's minimum 60 lumen per watt. So you ban incandescent lamps with 60 lumen per watt. You still have CFL on the market. Second year, we ban even more incandescent lamps. The second range of flex from 600 to 1,200. So the maps are 55, and you ban incandescent lamps at those levels, but you still have CFL. And year 3, you can see here in the picture, you have you don't have incandescent lamps anymore. So you have 3 years to ban incandescent lamps. You don't have incandescent lamps anymore, but you have CFL and LED that are still allowed on the market because they are higher than the maps. The efficacy is higher than the maps. Now, year 4, you can see the level, and then naturally, with this level, you increase the level, the minimum efficacy for every flex, and then you have only LED on the market. In year 5, you increase once again the level to have high-end LED on the market. So within 5 years, you ban incandescent lamp, you ban CFL lamps, and you increase the level of LED so they can reach the international standards, and especially the European standards, because in Morocco they are importing a lot of lamps from Europe, and what they want is to be as close as possible as from European lamps, European labeling of lamps, European information on lamps, and so on. So I did suggest once again a labeling based on the European one that will come into force in 1 year, or in 1 year, yes, now. So a labeling with letter from A to J, A, B, C, D, and so on. A is the most efficient lamp, and J is the less efficient. So here you can see in the table on the top left, sorry, you can see the from class A, for an example, for European Union. In European Union, you have to have efficacy higher than 210 lumen per watts. In Morocco, you cannot reach that efficacy right now, so there's lower maps, but the labeling scheme will be the same as in Europe. And that's very important for importers, for an example, to have only one labeling scheme. Okay, so now you can see on the yes, you can see the effect from year to year. Sorry, it's in French. From year to year on the labeling, what remains on the market, and year 5, for an example, when you have only high-end LED on the market, you have only A and B class lamps on the market. Why is it so important to have maps in line with labeling scheme? It helps market surveillance because it will be presented on Thursday. I think the euphoric approach is maps, labeling, communication, but also market surveillance. Of course, we have all stakeholders have to play the same game. Okay, a fair game. So we have to in our project, in our transformation of the market, we also help market surveillance with capacity building for laboratories and so on. So I think that's it from my side. No, one last slide, and last but not least, about sustainable public procurement. I am working right now, but it's now finished actually, on sustainable public procurement for street lighting and office building lighting. Yeah, because we talk a lot about maps, about efficacy, but efficacy is one stuff that's very important. But for sustainable public procurement, I did also include criteria on lifetime, and that's in maps, also modal regulation, but quality of light, color rendering index, the color temperature tolerances, some criteria for fundamental power factors, standby power, criteria on health for surge protection, impact resistance, and very important for Africa, humidity and corrosion resistance, let's say, or protection. And also one criteria which is not for the luminaire itself, but it's on dimming and performance criteria for installation. So that's really key, and that document is made for you, for collectivities, just to know what they can afford, what they should ask for manufacturer, and what are the important parameters, the important norms, and what are the levels in different aspects. So I think that's it. And those sustainable public procurement will be soon available. And now it's only for street lighting and office building lighting, but others will come certainly. Thanks a lot.
Thank you so much, both Bruno and Frederick, for the very interesting and useful presentations. Now I would like to introduce the Q&A session, but I still encourage you, if you have more questions, to contact both Frederick and Bruno. I will also share with you the introduction slides with their contact information. But for now, we have received some interesting questions from both of you. I will start with the questions for Bruno. So the first question, Bruno, is as follows. What areas, topics did you cover, or what did you look for during the workshops conducted for the minimum energy performance standards?
Yeah, thanks a lot for that question. That's a key point, actually. What we do during those workshops, we invite manufacturers, but also ministries, importers, retailers, and sometimes consumer association. And what we ask is, we did conduct a market assessment before, so we know what is on the market. We present the result to stakeholders. Do you agree? And so on that study, and so now we present the advantage of LED lighting, and we ask, do you think it's realistic to leapfrog directly to LED, or do you think, if you have incandescent lamps on the market, for an example, do you think we need time to buy an incandescent lamp? We need 1, 2, 3 years, or we can directly leapfrog to LED. The same for CFR. And we ask also for affordability. Of course, we address it during the market assessment study, but we take into account all that aspect. Do you need time to change? For an example, if you're a manufacturer, you have to change your production. If you're a retailer, also you have to sell your stock of all lamps and so on. On the other hand, we want to leapfrog directly to LED. So that's we ask for all stakeholders to give their point of view, and then we choose together. The goal is to make it applicable in the market, in the country. So we don't decide alone with ministry. We decide also with manufacturers and retailers. That's a key point.
Thank you so much, Bruno, for the response. Another question we have received for you. Phase ban of inefficient lamps looks like a good approach. What were the challenges in doing this in Morocco?
Well, Actually, a lot of challenges, but like in every country, I would say every country is different, and that's a very interesting job because that I'm doing, because you have to adapt to point of view of people. In Morocco, the biggest challenges were, first, you had 3 technologies in the market that were, and the LED market share was quite low. The biggest challenge for LED, because LED were not didn't have a lot of market share, but they were accepted naturally by people, and it was coming naturally. But the challenge was the energy performance, first, of LED that were sold in the market, and the lifetime. And lifetime was very poor, and quality of light. So there were LED on the market. That's a big story of LED. You have why you have so different efficiency from one LED to another LED. LED by itself doesn't mean anything. You can have high-end LED, but you can have very inefficient LED with lifetime less than 1 year, with very poor quality of light. So that was a big challenge in Morocco, to leapfrog to LED, so to ban 2 other technologies, incandescent and CFL, in a reasonable time frame, let's say, but also to increase the quality of LED.
Thank you so much, Bruno. That's very interesting. And as you can see, we also receive other questions, and those 2 last questions, they are for Frederick. What is your take on induction lamps, since they are also almost on par with the LEDs and also have a long service life?
Yeah, the induction lamps are very niche technology, and quite. I would say you have lots of issues with them, and you cannot just change the lamp with an induction lamp. It has to be tuned to the circuits it's in and everything. So to change an induction lamp, you have to change the whole luminaire, and they are a relatively expensive item, and they also use mercury, because it basically is a fluorescent technology with the mercury involved and excited by high frequency induction coils, which are in themselves a challenge for screening and radio interference. So it's a very niche technology, which is it's actually much more straightforward to use high power LED. And as you say, they're almost on the par. LED is moving at such a pace. If you were spending the money on an induction lamp, you could afford an LED which was probably 50% more efficient, because their money for an induction lamp is quite significant. So I would say it's a bit of a niche technology. There are some out there, but it's such a tiny proportion. LED is a much more straightforward and less hazardous technology. Shall I move on to a question? Yeah, move on to question 4. Is that me as well?
Yes, that's also for you. How to enforce minimum energy performance standards in a market flooded with low quality and cheaper products?
I mean, that is the key point about MEPS. They've got the monitoring, verification, and enforcement of MEPS is key. Without that, you cannot achieve the goal of accelerating energy efficiency. So these 2 things go hand in hand. And what we've done in the latest revisions is made the MEPS a much more simple structure to enforce. So instead of having lots of different things you have to check, it's just one simple efficacy level for each type of lamp. So for an ordinary light bulb, it's 1 level, like a base level of 80 lumen per watt. For a directional lamp, it's a simple base level. For a linear tube, it's a simple base level at 110 lumen per watt. And for a luminaire, again, a simple level at 100 lumen per watt, with a framework above it, so you can claim higher efficiencies and communicate that to the market. But the key point would be to enforce it on import of the goods. The vast majority of countries will import these products, and the way to control it is through import control, with a very straightforward requirement for certification from a recognized laboratory to prove that they are okay, and then to have an audit of those products to make sure that the claim is correct. And we're looking for local or regional accredited laboratories to do those checks. But we've kept it really simple, so the checks are relatively easy to do on more straightforward lighting test equipment. And the most onerous test is probably where you have to prove that it will last long enough to prevent early failures and poor quality. And that can be certified by a third-party laboratory, and you can do an audit locally. But we've tried to keep it really simple. But the message has to be that monitoring, verification, enforcement is a key part of the policy framework. And that is something that U4E would work closely with national authorities on to make sure they have access to an effective system to control it. Otherwise, you will never win. I have to say, one of the key planks of the new simple approach is that we've gone for levels that are going to be very affordable. So you can have quality lamps at the levels we're proposing. That's widely available from many different manufacturers. So the competition is good in that area. So you have a relatively good price product that still complies with the MEPS. So that should make it easier for monitoring, verification, and enforcement, because there won't be such a big opportunity for really poor quality lamps. You should be able to have a choice of supply, and therefore a quality product. But you do have to have monitoring, verification, enforcement system that works.
That's a very detailed response, Frederick. Thank you so much.
Sorry.
No, thank you. It was very comprehensive. And I would also like to thank Bruno, both of you, for the detailed responses to the questions. And now I would like to introduce our next speaker of today's training session, Clara Camarasa. She's going to be speaking about the energy efficiency building envelope. So Clara, the floor is yours.
Thank you, Begonia, and welcome everybody to the e-training session, Energy Efficiency in the Building Envelope. As was earlier introduced, and some of you already know my previous, or know me from previous sessions, my name is Clara Camarasa. I'm a PhD in Civil and Environmental Engineering, currently working in the Copenhagen Center on Energy Efficiency. And I'm very happy to guide you through the presentation today. A key component in sustainable buildings is an energy efficient building envelope. And with this insight, the objective of the session is to characterize key terms and measures to ensure energy efficient standards in respect to the building component. As in the last session, we will start with the theory block, which describes general aspects of this topic, which will take approximately 20 minutes. And then a second block, as most of you already know, which is a Q&A session, in which you will have the opportunity to raise any questions or comments. And this will take around 10 minutes. Starting with the definition, the building envelope is the physical separator between the interior and the exterior of a building. Components of the envelope are typically walls, foundation floors, roofs, fenestrations, and doors. Fenestrations refer to any opening in the structure, such as windows, skylights, etc. The building envelope serves many functions, and these can be broadly divided into three categories. First, the support, to ensure the strength and rigidity, providing structural support against internal and external loads and forces. Then control, controlling the exchange of water, air, condensation, and heat between the interior and exterior of the building. And finally, finish. This is more related to an aesthetic purpose, to make the building look attractive while still performing the control and support functions I just mentioned. But when defining the building envelope in the context of energy efficiency, it is also important to distinguish between two key terms, building envelope and thermal envelope. The building envelope is the physical separator between the interior and exterior environment of the building, including air, water, heat, light, and noise transfer. Whereas the thermal envelope of the building is the union of those structures that separate the conditioned part of the building, meaning the space being heated and or cooled, from the outside or from other parts of the building that are not conditioned. From an energy perspective, the envelope is a composition of layers with varying thermal and permeability properties. It may be composed of membrane, sheets, blocks, and pre-assembled components. The choice of the envelope is governed by the climate, as we will see in the next slide, culture, and available materials and resources. The range of choices in the envelope design can be illustrated by two opposite design concepts. the open frame, and the closed shell. In harsh climates, the building envelope is typically conceived as a closed shell as possible and proceed to selectively punch holes into it to make it limited contact with the outdoors. This may also be true when there's any unwanted internal or external influences such as noise or visual clutter. When external conditions are very close to desired internal ones, the building envelope often begins as an open structural frame with pieces of the building skin selectively added to modify a few outdoor forces. Now, coming to what I mentioned earlier in terms of the different building or different climate conditions, it is important to note that a well-designed envelope responds to the local climate. This slide shows the three distinct extreme types of climate: arid, cold, and tropical. In each case, different strategies can be implemented. Milder climates, however, can use milder version of these strategies or a mix or match of them. First, arid climates are very dry and usually hot, but they often have large swings of temperature from day to night. Thus, thermal mass of the outside of the building is the most crucial design strategy to even out such temperature swings. Some design strategies for an energy-efficient building envelope are high ceiling, shaded breezeways, light colors for the facade, and daylight via reflected light and not direct light. You can see an example in the Master City on the picture to your left. The next type of climate is cold climate. These have many more heating degree days than cooling degree days. Therefore, maximizing insulation is key to keep the building warm, as well as using windows for solar gain on thermal mass in the building envelope, unlike the arid climate we just saw. Part of having an effective insulation in cold climates is an airtight envelope, avoiding infiltration at all costs. Also, having small and well-selected openings. The Swedish cabin you can see in the slide in the middle is a good example of this. It has very few and very small windows except to the south-oriented facades to maximize solar gain while minimizing losses everywhere else. Finally, tropical climates, as in the case of Mozambique. Tropical climates are hot and humid, therefore keeping the heat of the sun off as well as maximizing ventilation is a top priority. The ideal is a reflective, insulated roof with walls that pass breeze but not rain. The educational school represented in this picture, at your right, shows the thick light-colored thatched roof, keeping out the sun heat away, while opening eaves and porous bamboo slats for the walls and floors to maximize natural ventilation. The materials are all low mass to avoid condensation and mold growth. Now, in this presentation, I will focus on those measures that are most relevant for the characteristics or energy efficiency measures and characteristics for the building envelope, focusing on those most relevant for the Mozambique context. Now let's have a quick look at overarching building physics terms and concepts that are necessary to better understand the energy efficiency in the building envelope. Starting with the heat transfer. Heat transfer is a process of thermal exchange between different systems. Generally, the net heat transfer between two systems will be from the hotter system to the colder one. Heat transfer is particularly important in buildings for determining the design of the building fabric and for designing the passive and active systems necessary to deliver the required thermal conditions for the minimum consumption of energy and resources. The mechanisms of heat transfer can be described as conduction, convection, and radiation. Convection is the transfer of heat by moving air, like warm air rising to the ceiling. Conduction is the transfer of heat through solid materials, such as heat being transferred from warmer section of the walls and ceilings to cooler areas. And radiation is the transfer of heat in the form of electromagnetic waves, such as heat being transferred from the roof of a house to the ceiling. Heat tends to flow from a higher temperature to a lower temperature zones by all three of these mechanisms. The rate of heat flow by any of these three forms is determined by the temperature difference between the two zones or areas that we're considering. Therefore, the greater the temperature difference, the faster the rate of heat flow. Optimizing the heat transfer through walls is very important in the performance of a building design. Thermal mass and installation with passive design strategies can reduce the amount of energy that active systems such as HVACs need to use. Resistance to conduction is measured by the R value. A high thermal resistance requires a R value. And the insulating performance is measured by the U value. The lower the number, the better the installation performance. In this way, the U and the R value are reciprocals. As I mentioned earlier, the thermal mass of the building envelope helps to reduce the indoor temperature swings and often leads to reduction in the size of mechanical heating and cooling systems, which is one of the biggest sources of energy use and cost in a building. The basic premise is simple. As you can see in the figures to your right, the thermal mass absorbs the heat from the surrounding area when it is warm, and it radiates it back out as cooling afterwards. Typically, this means that the mass is absorbing heat during daytime, helping to keep the space from overheating, and then radiating it back, helping the space to be appropriately warm afterwards. If you have ever walked into a Masonry church or monument during the summertime, for instance, you have likely felt the pleasant temperature difference immediately, and then realized that there's likely no air conditioning at play. This natural ability for masonry, for example, to absorb and store heat produces multiple benefits to the occupants or users of the building, including peak heating and cooling loads can be reduced since the high and low temperatures of the space are moderated and temperature variations are reduced. Peak heating and cooling loads can also be shifted to non-peak hour savings. And also, the size of the HVAC systems can be reduced since the high and low temperature points that the systems need to perform are likely to be trimmed. Hence, less heating and cooling capacity is also needed. Use of thermal mass of materials in the building envelope is a viable energy efficiency strategy. Considerations must be taken, however, from the selection of the materials, location, orientation, ventilation, and many other factors in order to achieve an effective performance. To determine the thermal mass of a material, we have to know its volumetric heat capacity, which can be found by multiplying its density by its specific heat capacity. As you can see in this table, heavyweight materials such as concrete and bricks have a high volumetric heat capacity, and therefore a building constructed from these materials would have a high thermal mass. On the other hand, lightweight materials such as timber and insulated panels have a lower volumetric heat capacity and low thermal mass. Let's now have a look at insulation. Insulation is primarily designed to prevent heat transfer from conduction and radiation through the thermal envelope. It is typically measured by emissivity. Although insulation can be made from a variety of materials, it usually comes in 5 physical forms. These are bating or blankets, blown-in loose fill, foamed in place, reflective and rigid boards. In terms of bating blankets, these come in the form of bats or continuous rolls that are hand out or trimmed to fit. They're stuffed into places between studs or joints in the building facade. Benefits of this type of insulation is that they're common and easy to install. In terms of the blown-in or loose fill insulation, these consist of loose fibers or fiber pellets that are blown into the building cavities using special pneumatic equipment. These best forms include adhesives that are sprayed into the fibers to avoid settling. The materials that are used for this type of insulation are fiberglass, rock wool, or cellulose. And the benefits are that they can provide additional resistance to air filtration if the insulation is sufficiently dense. In terms of reflective insulation, these are rolls of foil integrated into the building wrap or into rigid insulation boards. These kind of radiant barriers are typically located between the roof rafters, door joints, or wall studs. And the benefits is that they can resist radiative heat transfer. And given the resistance of the heat flow that depends on the heat direction, they are most effective in reducing downward heat flow. They're most effective also in hot climates rather than in cold climates. In terms of the foam in place, these are installations that are sprayed directly into cavities within the buildings, where it expands and it sets to fully seal the cavity. Benefits is that of these type of installation is that they can fully seal the cavity, helping to reduce air leaks. The spray foam, once set, is rigid. It can help provide some structural shear strength also to the building. It generally has high R values and also provides acoustical insulation if needed. Now, finally, in terms of the rigid boards, these are plastic foams extruded into boards or fibrous materials pressed into boards. They can also be molded into pipe coverings or other three-dimensional shapes, which are indeed a benefit in terms of this type of insulation. But another type of benefit, or another benefit, is the fact that they're very lightweight and provide structural support, or can provide some kind of structural support to the building envelope, and have generally very high R values. Moving on to glazing. Good glazing properties are important because they control the amount of daylight, the quality of the light, and solar heat gain let into the building, along with other factors, of course, in terms of energy-related factors. They very much determine the thermal and visual comfort of the space. 4 of the most important properties of these materials include, first, the thermal conductance, measured by the U value that we explained earlier. Second, the solar heat gain coefficient, which is the fraction of solar radiation admitted through a window, door, or skylight, either transmitted directly or absorbed and subsequently released as heat inside the building. And therefore, the lower the solar heat gain coefficient, the less solar heat it transmits and the greater its shading ability, which is very useful for warmer climates. The visible light transmitter is another important parameter. This is the amount of light in the visible portion of the spectrum that passes through a glazing material. This property is important to control the visual connection to the exterior of the building, such as the views, for instance. Finally, the shading coefficient is a measure of the heat gain through the glass from the solar radiation. So a lower shading coefficient indicates a lower solar heat gain. And this will be, again, optimal for warm and sunny locations such as Mozambique. Appropriate values for glazing properties vary by climate, size, and placement of the aperture. But also they're conditioned by the cost or other resources. And therefore there is no best kind of glazing to use, but the appropriate according to these conditioning. But what makes an energy efficient window? 5 main characteristics can be highlighted. First, the quality of the frame material, as they can reduce heat transfer and help insulate better. Also, the multiple panes, 2 to 3 pane glass windows with an air or glass-filled space in the middle insulate much better than a single pane of glass. Also, low E glass. These are special coatings that reflect infrared light, keeping the heat inside in winter and outside in summer. Also, the warm. Gas fills. Some energy efficient windows have argon, krypton, or other gases between the panes. These odorless, colorless, and non-toxic gases insulate better than normal air. And finally, warm edge spacers. A spacer keeps the window glass pane the correct distance apart. Non-metallic or hybrid spacers also include pane edgers. I must say that energy efficiency window is usually a very low-hanging fruit in terms of an energy efficiency measures that can be implemented in a building envelope. As it has a very low cost, can be easily replaced, and has a very positive impact in the energy demand and therefore bill of the building. Another energy efficiency measure related to the building envelope is shading and or redirecting the sun. It entails an important set of strategies for visual and thermal comfort. Shading strategies include overhangs, louvers, and vertical fins. Light redirection strategies include light shelves and buffers. All of these strategies can be external to the building or internal, and can be fixed or put in a fixed position or adjustable. Some elements are able to give both shade, but also redirect light at the same time. Both thermal and visual comfort should be considered simultaneously when designing these elements, as they affect both. Shades can keep the heat and glare of the sun from coming through the windows, while still allowing diffuse lights and views to enter. They can also keep direct light off the walls and roofs to reduce cooling loads. Interior shades do not block solar heat, but can block glare and even out the light distribution, which is also important. Now let's have a closer look at the solar control and shading devices. These can be provided by a wide range of building components, including landscape features such as mature trees or hedgerows, like in the case of the Repsol campus in Madrid from the picture to your far left. Exterior elements such as overhangs or vertical fins. Low shading coefficient glass in line with what we mentioned earlier. And interior glare control devices such as Venetian blinds or adjustable louvers, as you can see to your right. But these are just some of the terms, concepts, and solutions needed to understand the fundamentals of energy efficiency in the building envelope. Yet again, as mentioned in the earlier session, the building works as a system, exactly like the human body, where all of the parts of the system need to work together to function properly. Inasmuch as the thermal mass and insulation with design strategy of the building envelope can reduce substantially the amount of energy that active systems need to use, such as HVAC systems, these still need to be aligned with the other building components for an optimal energy efficiency in the building, such as HVACs, lighting, appliances, etc. Which is another good reason why I would encourage you to not miss the upcoming sessions of this training. And having said this, I thank you very much for your attention and hope this was interesting and useful for you, and look forward to any of your questions. For any queries or issues beyond the Q&A session, please don't hesitate to contact me or visit our website, as Begonia mentioned earlier. Thank you very much.
Thank you, Clara, for your presentation on the building an envelope. It was quite detailed and interesting. I hope the participants have gained a lot through that presentation. Yes, hello everyone. I am Rahul Dusa. I will be continuing today's training now. So last week we have covered the topic on energy audit and management, that is on 19th of November. This introduced, to the participants with all the energy audit and energy management, that is actually what exactly it is, where all this can be applied, why this is actually important to any organization, firm, a building, or an industry. And also we have seen a step-by-step approach on how we may implement and adopt this. So today I will be continuing with module 2 and I will talk about energy management and audit for buildings in particular. The session will be more or less in line with the previous session where we talked about the energy audit and management in particular, in general. So I will not be very detailed of what we covered earlier, but will also adopt the similar structure and present it with buildings perspective today. I will be directly getting into how we conduct this energy audit and energy management and how it is applied for the buildings. So if one has to gain more out of today's presentation, then I would recommend them to, if they have not attended the previous session, that is module 1.4, please do go and attend that sessions. The presentations and the video will be uploaded quite soon on our website also. So when you talk about buildings, they could be of any type and used for some specific purpose. For our presentation today, I will be mostly referring to the content that is widely applicable for, let's say, educational, institutional buildings, or businesses, or industrial type of buildings, or storage and commercial type of buildings. To a certain extent, this can also be applicable for the residential type. We will see how energy audits are conducted and how energy management is adopted in the buildings now. So yes, regarding energy management, we will revisit this information about exclusively with respect to buildings. We have discussed earlier about the 4 different factors that are necessary for a successful energy management. So yes, technical ability. It's about, does the organization have the technical ability to understand the energy terminologies? In buildings perspective, do you have the knowledge of different passive and active systems in place and how they operate and how you maintain them? Regarding the monitoring systems, it is in the building. It could be about following the energy consumption trends, checking your insulation health or lighting lux levels, or further details and how your HVAC systems are functioning. You can also monitor your occupancy levels to come up with various ways to optimize your energy consumption levels accordingly. And yes, of course, how effectively you are actually using your utilizing your building management systems. Do you even have a building management system in place, if applicable? Strategy plan, yes, for buildings is more or less a similar approach that we've discussed in module 1.4. Of course, the nitty-gritties with respect to the departments covered and the components that had to be dealt with will be have to be customized for the building sector. And of course, management support is required, and it is inevitable to initiate anything. So the energy management principles remain the same. They may not be as extensive and as compared to a complex industry here, mostly because the number of divisions, the departments, the roles and responsibilities, the components are slightly less complex, and with respect to the buildings. The number of personnel involved also generally few. Generally, often it so happens that there is a facility manager and a small team of technicians or engineers who generally take care of everything with the support of the administrative staff. So we will quickly go through the steps again, and I will keep referring to the buildings exclusively wherever necessary. Number 1, the management support. Well, they have to assign a building energy manager that they have to be appointed. The building energy manager can be hired, or it can be someone from internally. It could be the facility manager or the electrical or mechanical or technician who is in charge of day-to-day operations. Then yes, you need to have an energy team who will be, as we discussed earlier, basically consists of representatives of all the associated divisions or departments within the building complex. If it's a commercial building or let's say a hotel or a hospital. Why I am actually stressing a lot with the team composition is because often energy efficiency activities get stuck in waiting for approvals or making other departments or divisions understand the whole idea. Many times proposals are really attractive, but they are on hold because they are not prioritized, or other important personnel did not understand it. So yes, team is important. Of course, for a small office space, you would not have this level of complexity anyways. Yes, then again, I've also discussed about the energy policy drives, how important they are. Coming to point number 2, the energy performance assessments. It is about monitoring your data. Basically, you have your BMS building management system in place because to control your mechanical and electrical systems. Are you collecting and monitoring the data parameters? You will be required to set a baseline. What is my present energy consumption? My energy cost. For buildings, it could be the electrical energy for appliances, the different active components. Gas could be for space heating or hot water requirements, or even for cooking. Energy metrics are calculated. We discussed about these different energy metrics and specific energy consumption details in module 1.1 and 1.3. For buildings, often the metrics used are energy performance index, that is kWh per meter square per year. basically your annual energy consumption divided by the area. Once this metrics are defined, you can set this as a baseline figure. You also set a benchmark figure. Benchmark figures are used for a reference, something that drives you to become better, that defines your action plans and goals. Depending on the type of location, type and location of the building, you will have your benchmarks set. So basically, you compare your building's energy metrics with the best values among. Remember, you have to remember that the comparison should be somewhat similar. That is, if you are evaluating for an office building, then you have to compare your metrics with another office building. Likewise, if you have to compare a commercial mall building with another mall, or a hotel with another hotel. The extent of granularity is up to you again, but remember, in short, it should be more like comparing apples with apples. So all this evaluation of EPIs and efficiencies are done generally through energy audits and technical assessments. Number 3, goal setting. It's about once you actually set your EPIs and metrics, baselines and benchmarks, you would be defining the scope and the goals. So you know where you are, you decided where you want to reach, and the difference is what your estimated improvement requirement is. So through energy audits and technical assessments, you will know how you can achieve those goals. So based on these recommendations, roles and responsibilities will have to be assigned to your staff and other building personnel. Implementing the action plan. Let's say I have installed a variable frequency drive for a pump with pressure feedback, so that the pump operation and the power consumption is taken care automatically based on the user side water demand. And then, of course, someday someone comes who is not aware of the setup and then starts opening and closing the discharge valves of the pump's pipeline. Then it would defeat the very purpose of installation of a VFD, a variable frequency drive. So yes, to an extent, I would say communication, creating awareness, and training is important. I have seen in many buildings, the canteens and other common spaces where they set up these big boards and slogans or posters, with list of actions on energy efficiency drives and all. You could have also competitions on best innovative energy conservation ideas. This way, the staff also gets motivated and feels included in the building energy efficiency drives. Number 6, progress evaluation. Yes, you have set your baselines. You agree. You should again measure your these parameters under the similar conditions to see where you stand now. And I actually also talked about this baseline and boundary setting in the module 1.1 and 1.3 presentations. So you compare your values, past and present, and then see if you have reached your benchmark figures, or if not, how far you are from that. You should be a good judge by now, understanding if your action plans really worked, or you may have to review them. So yes, the energy audit types will be same, preliminary and detailed energy audit. The principles of preliminary energy audit would be more or less following the same pattern. For details, please do refer to module 1.4. Today, we will be taking an example of how it is applicable, or in what way. An example for exclusively for buildings. Let's take an example for energy efficiency drive in municipal buildings. So a municipality plans to improve energy efficiency in the building sector. The municipality, has a list of different types of buildings and their usage purposes under their jurisdiction. So now to start, it would not be an ideal way to say that I will target, or the municipality should target all the buildings in the first phase. Imagine there are some hundreds of buildings, so all 100 of them need not be targeted at right away. All possible rules and laws of the municipalities with reference to energy efficiency may not be applicable to all these hundreds of buildings in the same way in a practical sense. So the recommended approach would be to first understand the energy metrics of all these buildings and possible potential of energy reduction, right? So this is when you have this preliminary energy audit approach very helpful. the municipality can hire some energy audit consultants or experts or firms and distribute these hundreds of buildings among them, and then they can ask to do a quick preliminary energy audit. The distribution may be with respect to the locality or type of buildings. So we discussed these steps earlier. The first one is establishment of energy consumption. Let's say these energy audit teams which the municipality hires would visit each of these buildings assigned to them and quickly collect the energy data here. Not much depth, but basic data like annual energy consumption, that is kWh of electricity, or meter cube of gas, or the area of building establishment. They would define what the EPIs are, what the other energy metrics are, identify major energy consuming areas. Usually would be the HVAC systems, the lighting, and if possible the compressed air systems if it is an industrial building setup or a multi-specialty hospital setup. Number two, scope for savings or energy are estimated. So basically, based on the type of energy used, the equipment, the age, the technology, the energy auditing team would be estimating the potential scope for energy savings. For buildings, let's say you can have this identifying of scope for potential areas based on the existing lighting fittings, or the motor and pump efficiencies, or the application requirements such as space heating, hot water generation, cooling capacities, and the requirements. For example, it's like if I'm not having a proper insulation for my pipelines, or there seems to be some significant heat gain through windows, maybe due to the orientation of the building, or the type of glazing, the window types, or the walls, then yes, the auditor would be able to suggest that there is a scope here. It can also be about how am I catering to my space heat requirements. Do I have the scope for installing heat pumps to reduce my dependency on gas-based, diesel-based boilers, or then yes, there we can say the auditor can say then there is a certain scope there. Number three, it's about finding out the easiest areas for attention. They are identified. For example, if you have a low energy label rating air conditioning unit that operates for a longer duration, then the auditor or the auditing team can quickly estimate the savings if replaced by, that would be achieved if it is replaced by a higher energy label rating air conditioning unit. As we talked earlier, the installation of occupancy sensors or indoor lighting and ventilations, the photo sensors or timers for outdoor lightings, all these can come under this identification of low-hanging fruits, where there is not much of complex calculations that will be required and assessments that will be required. There is a phase wherein the step 4, wherein the areas that are required, where the energy auditing team would identify the areas that might require a detailed study. So let's say, for example, something on evaluating the HVAC performances, or measuring the air flows or water flows, evaluating the kilowatt per TR or COP values or energy efficiency rating values. So something like this, maybe getting into more details, building simulations to optimize heating and cooling loads. So all these may be requiring more in-depth study, and maybe may not be actually taken up during the preliminary audit. However, the energy auditor or the energy auditing team should be able to note down these potential improvement areas among these, and then if required, a comprehensive detailed energy audit may be taken up in the later stages. And then finally, it is about where the setting up a reference point, that is where the building actually stands at that point of time with respect to the energy profile. So yes, please note that again, the preliminary energy audit uses existing data or easily obtained data. No heavy measurements or assessments are done during this phase. So something like this, the municipality can then consolidate the data from preliminary energy audit reports. They can then see the type of buildings, numbers, emphasize on necessary subsequent energy efficiency steps with respect to energy consumption of so the necessary energy efficiency steps the municipality can take a call with respect to the type of buildings, or with respect to the sectors or sections where there is highest energy saving scope. This way, you can target a particular type of building, or you can see the scope of areas and take your actions through probably project bundling. For example, let's say if a commercial sector or commercial buildings are consuming a lot of energy at the highest energy consumption category in the total sector, in the total section of buildings, then you would want to target that one. If you or your decision can be based on, let's say, certain office buildings or healthcare buildings have a higher potential savings, then the municipality can target first that one. Or if you see that there is a lot of scope on lighting improvements, so that way the municipality can probably aggregate multiple buildings and then see how effectively the business models can be worked out for catering to only or targeting only lighting sector. So as we discussed earlier, detailed energy audits are actually very detailed. So I will try to give out the best and maximum information in the time that is available to us. For any further details, please do write to me for further discussions. I will follow the same 10-step approach which we covered in module 1.4, but of course, more emphasis on buildings. Yes, instruments are generally standard based based on the parameters you intend to measure. So again, for buildings, you will be needing the ultrasonic flow meters to measure the chilled waters or cooling water flow rates. For example, power analyzers to monitor different aspects of different components or appliances power parameters. The thermograph is quite important. It plays a prominent role in identifying the heat gain or heat gain or loss via windows, leakages through doors, or identifying any damaged insulations or air ducts where you cannot actually make out through naked eye, and so on. Phase one, it's actually a pre-audit phase. It's about. I will again emphasize or stress here that it is how effectively the auditor carries out this stage. It actually defines the success or the smoothness of the rest of the energy audit course. So quickly, the auditor would be planning and organizing, would carry out a walkthrough audit, and then have quite a few interactions with the building personnel or the management. This phase again, it's important because it helps you in planning resources such as team, time, instruments. May possibly so the energy auditor or the team can actually possibly share a questionnaire to collect the important and useful information first during this phase. I'm sharing some formats here, examples of questionnaires and type of data that can be collected. For example, building details like what is the name, its address, who is the point of contact person, what is the designation, so that for future interactions and coordination, it makes the activity or the process simple. And then there are overview of energy sources to have an idea of the types of energy used, the quantum and cost of energy used, also some major energy consumption points. This is all in the first phase. More technical data on energy parameters or power parameters. Some technical data on, let's say, for example, transformers or electrical systems are collected or requested via the questionnaire. Like, for example, you see here, if I'm talking about transformers, what are the number of transformers, what is the type, capacities, where it is located. So all these data will be very helpful for the auditor and the auditing team to during the actual course of study. Similarly here for the motors, if you see there how many number of motors are there, what are the different types of motors installed, the capacities and operating hours. Similarly, some technical data for HVAC systems are collected. So yes, the auditor would be collecting basic data on numbers, types, usage, capacities, etc. for all these equipments and components like fans and blowers, lighting equipments, building envelope components through the questionnaire. So based on the data that is collected by the energy auditor, they will have an idea on the size of the building, the complexity or the time it would take to complete the audit. So they would plan their resources, such as the instruments, for example, I've shown here. So based on the data that they have collected, for example, would decide that these are the instruments that they have to be carried to the building for the energy audit purpose, and numbers. And then, of course, a plan for the professionals or the energy auditors required for the team. Let's say, based on the data that I have, I would be needing some 3 people who will be taking care of the electrical and automation segment. Then probably another 2 people who will be taking care of the mechanical side. If it is an industrial process or a food process building, something like that. Then a chemical engineer might also be required. So depend. The team can also consist of an architect or a building expert, apart from all these experts. Of course, the team, the energy auditing team, will be providing or sharing the plans and timelines so that the management will ensure that they allocate their staff for the support that is required on a set date. So on this date, I would be allocating these personnel, will be carrying out the various auditing works and these sections. So that way, the management or the coordinating members also will be able to allocate certain personnel from their end to support the activities. Tentative work plan also, basically to share and understand what are the different areas, what are the different deliverables that will be done, and by tentative dates. Step 2, it's same again. The energy auditing team would conduct brief meeting with the divisional heads or the building management. So we did discuss about this earlier, why this part is very important. Step 3, you move into the actual audit phase, where the team that has collected, the energy auditing team, which has collected the data of primary data, historic analysis and all. So based the design on the operating parameters, operating schedules, all these things will be collected, which have been collected. This can also be something similar to collection of flow diagrams or utility diagrams or energy bills and all. Can all be falling under the primary data. Buildings exclusively, you may have to focus on this above mentioned categories also, where especially if the team or the energy auditing team intends to also conduct some simulations or heating and cooling load estimations. So step 4, an in-depth survey of monitoring will be done for individual areas in the building. So the energy auditor would be comparing the first-hand collection and operating data or the design data, which with the comparison is done with the ones that was shared with the facility through or the building through the questionnaire responses. Why comparison? Because often it so happens that the answers or the responses received via the questionnaire do provide a direction for the auditing team, but most of the time they do contain some the information that are quite outdated or not quite updated. Some of the sample questions the auditing team may ask the staff during the survey and all. So an example for design details that the energy auditing team may take note of during the in-depth survey. If you see here, this is for chiller details, let's say air conditioning unit details. The depth of data that they have been collecting here, this is design details, not be actually being collected during the initial pre-audit phase, because this is quite time consuming, and they need to be quite sure which areas they are actually targeting first. Requires in-depth study. So only when they get into the in-depth survey mode, they would be taking more detailed data. So yes, the energy auditing team will start conducting detailed experiments or trials on energy intensive areas. It could be different, like say the maximum demand parameters, or power factors, or the kWh units, etc. Basically, at this step, detailed performance evaluation and efficiency trials are done through various set of measurements. This I have already shown using a power analyzer to connect it to the panels that to capture different power parameters. and this also the chilled water flow measurements through using the ultrasonic flow meters. So yes, I'm showcasing an example here for one of the buildings, the transformer loading and operational trials for a building. The power analyzers were actually connected to the panels, data was recorded and analyzed. So here in this case, it is about parallel operation trials for the transformer. Basically, they're trying to distribute the load on both the transformers equally, thereby reducing the load losses in the more higher loaded transformer in the process. So, of course, you would not simply accept mere recommendations by an energy auditing team, right? So the energy auditor has to get some data, measurements, numbers, something right, so that to justify their recommendations. So here in this case, the energy auditor was showing that the transformer losses can be reduced by operating two existing transformers in parallel with equal distribution of electrical loads. That is the proposed scenario, if you see, as against the then existing scenario where you see the load of one transformer is higher than the low and the other is low. So yes, please note that I am only talking about these steps and giving examples here. The applicability of this measure may or may not be valid for your individual buildings again. Trials and measurements samples showcasing loads, trend studies, and detailed measurements of harmonics of the electrical systems for the buildings here. Examples again for conducting trials and monitoring performances for chillers, evaluating cooling loads, specific power consumption at different time points, if you see here. On the right, there is example of analysis showing the pump operating with VFD, variable frequency drive. Trials being taken and pump efficiency being evaluated at different operating frequencies. As mentioned earlier, the energy auditor would showcase these values and then justify why a pump may have to operate at a certain frequency to suit the system operational needs. I understand this can be this is getting a bit more technical, but please just the end point is you need to understand that the presentations are done just for the as an example purpose, so that you will have an understanding of what all goes on in energy auditing practices and under especially in this particular step. Step 6 is again, you will be conducting detailed analysis. Once the measurements are done, you will start doing the analysis of how you use your energy. Material balances and energy balances are done to understand what are the different inputs and what are the different outputs. So, for example, here you see for a building in the energy use of a building, this is an example here, how electrical consumption of HVAC varies over the week or lighting consumption varies over the week. Based on the data what we collect from the power analyzers and all. So it would give you an idea, what all loads are operating on weekends and weekdays. This kind of data analysis can, enable you to investigate further. For example, I see here on Saturdays, the HVAC load is showing some significant value here. So then, further be interested to know why or what is it actually causing that HVAC loads rise on Saturdays, because let's say my office building is actually closed on Saturdays and Sundays. So this way I would look into more details, investigate further what is actually happening on Saturdays. Similar example for load distribution and balancing for energy and power measurements here. Detailed analysis can also include energy balances. The figure on the left shows an example of heat balance in a building. The heat input can be due to sun's radiation, that is, heat gain due to sun. The internal loads due to people or electrical appliances or equipments. Heat loss, on the other hand, can be due to ventilations or different heat losses, leakages from through envelope. It can also be heat gain if it is if you're referring to a cooler place, a cold place. The right picture gives you an example of a Sankey diagram, actually accounting for heat and energy, heat and electricity energy inputs, the components or equipment that converts this energy into desired form of energy. and then the remaining is showcased as various forms of losses. So the energy auditing team will be developing the proposals, then interacting and conducting some brainstorming sessions with the building personnel to finalize these proposals. And then depending on under whose scope this is, the building management or the energy auditing team will contact the vendors, the suppliers, or technology providers to see if the necessary recommendations can be actually implemented. That I mean, for the implementation, the required technology or the equipments are actually available, or the material resources are available, and if available, at what cost. Further, the cost benefit analysis is done. So you have estimated your energy savings. You multiply these per cost energy unit, find out what is the energy cost savings. Then you also evaluate what is the payback periods, and you prioritize your implementation strategies accordingly. I'll show you an example here again. Basically consolidating how you consolidate your energy conservation measures and cost saving potentials, the investment cost for the said energy conservation measure, and the payback periods. So here I'm giving an example for different energy conservation measures that were identified for electrical systems. So for each measure, you have individual what is the actual cost saving that energy saving, and then equivalent cost saving, what is the investment that is required for carrying out this measure, and what is the payback period. Similarly, I am showing here the example for energy conservation measures for, let's say, for HVAC systems. So you have the measures for HVAC systems, different measures. What are the different saving potentials? Saving potential, what is the investments that will be required, and simple payback periods calculated. So based on your payback period, as you've seen in the last column, you can actually decide which measures you want to take up immediately, and which energy conservation measures you want to allocate, select certain budget and plan to take it up sometime in the future. For example, if I would target, I would first target the energy conservation measures number 1, 3, and 4. Since there is barely any investment needed, I can take it up immediately, and I would be profiting out of it. If I would, then the next target would be something like the number 2, where the payback is somewhere near close to 1 year. So it should not cost much for me. I will be immediately mostly getting my returns for the investments that I have done on this measure within a year. Then in measure number 5, maybe it might be needing some planning and budgeting to be set aside, and then take up when the funds are sufficient, or maybe the building management based on the building management's future plans. Because let's say if you are expanding or you are doing some modifications, then this would not be a good idea to take up now, or something like that. And of course, the auditing team will be preparing a report containing all the details which I have discussed earlier about data recorded, what are the different calculations, technical and economic assessments, detailed proposals and recommendations. A formal closing presentation will be done to the top management, who will be the final decision makers, of course. And then, as I mentioned earlier, a good and reliable energy auditor would be further assisting the building with implementation of energy conservation measures that they have recommended. It also depends on the agreement conditions, of course, between the energy auditing firm and the building management regarding the post-audit phase activity engagements. But however, this is highly recommended that the engagement still exists, and they continue to interact throughout the implementation phase. So we can actually discuss this for hours on this topic, but again, we did discuss earlier that time is also an important resource, and we may have to value it. So nevertheless, further discussions and queries, if you're interested in anything specific or in detail in what I have covered till now, please do write to me in the email mentioned here. Thank you for your time. I will be back for some other topics again down this week. I will now hand over the floor to Begonia.
Thank you so much, Rahul, for the presentation, and also thank you so much, Clara. Now we will have the last Q&A session, and we have received some interesting questions for both Rahul and Clara. And I would like to start with the questions for you, Rahul. The first question is as follows. What is the difference between an energy management system and building management system?
Okay, so building management system, it's also often called as a building automation system. It's basically a computer-based control system that is installed in buildings, mostly that controls, monitors the building's mechanical and the electrical equipments, such as the ventilation, the lighting, power systems, the fire and security systems. All these are managed or controlled by the building management system. The energy management system, in management terms, it is about your goals, roles, and responsibilities in cutting down your energy costs. But I understand the question is being referred to the monitoring part as a helpful tool. So the energy management system here can also be a system of computer-aided tools, I would say, used by the operators of, let's say, it can be the electrical utility grids, but in case of the buildings, it could be someone who is monitoring and controlling or optimizing the electrical usage or fuel usage at different sections and segments. So it's basically, the differences I would short down would be like maybe the building management system is primarily about real-time control. I would say it is about how you actually operate and control your operating systems. Again, these are not actually you may or may not have at times that is what I have observed, that these systems are not actually often built for dealing with the historical data or reporting. It is real-time updates that you keep taking actions on to control your systems. The energy management system is again more of reporting and decision-based tools. So it's more like often you have a dashboard on place with energy data, and you track the trends of consumption throughout your historical data, so that it helps you to decide what is your next step based on your past historical data, your energy consumption data. So yes, actually, if you see, most of the buildings often combine these two systems. They integrate these two, so there is often a confusion at times between what is energy management and what is building management systems. Yeah, thank you.
Thank you so much, Rahul, for the explanation. And now the last two questions, they are for Clara. So Clara, the first question for you. Looking at the amount of material for building envelope, looks like it makes the building expensive. Based on your experience, is it feasible if compared with the savings benefits?
Thank you, Begonia. That's an excellent question, actually. It very much depends on the specific case, building by building, the different contexts, the resources available, the climate, weather conditions, etc. Based on that, the amount of measures or energy efficiency measures that could be implemented in the building would be more or less cost benefit, and it should be studied on an individual basis. So in my presentation, I hope that was not misleading. I did show the whole repertoire or the whole palette of energy, at least some of it, of energy efficiency options for the building envelope, but that doesn't mean all of them should be implemented at once in each building and in each case. As it's hinted at in this question, it should be studied case by case, see what are the available resources, what is the budget, and what is the climate, what is the use of the building. That also has a huge impact in terms of the available options or the most suitable options, I would say. And all of that should be assessed together to really see what should be selected. But I can already say that once that process has been consistently gone through, most of the energy efficiency measures that are implemented in most of the cases that we have studied, indeed, those are feasible, and their cost benefit in terms of the energy savings that can be obtained through them. So I would say if well selected, in a nutshell, I would say, if well selected, indeed, they are cost-benefit.
Thank you so much, Clara. The last question for you is, are floors also part of the building envelope?
And that's a very good question again. And that's the question that was often popped up when I was giving lectures in the architectural university or to students of architecture. Yes, so it's a very common doubt. Floors that are part of the foundation of the building are considered as part of the building envelope, but not the floors that are not part of the foundation and are classifying different floors in the building. So different slabs in the buildings. Those are not part of building envelope, but those that are part of the foundation are considered as the building envelope. So the horizontal plane of the building envelope.
Thank you so much, Clara. And also thank you so much, Rahul, for the detailed responses to the questions. Well, ladies and gentlemen, finally, we come to the end of this training session. I would like to say thank you to all the panelists for the informative and interesting presentations, and to the audience for their active participation. We hope that the presentations will be beneficial for all stakeholders involved in energy efficiency. I would also like to mention that the presentations will be available soon, and the recordings as well, as mentioned at the beginning of this training session. And thank you so much for your attention, and wish you a good day or night from Copenhagen.